All right, hello everyone, and welcome to this month's Code Harbour. I can't wait so I can do that in person. You can all join in. So, anyways, thank you. That's made me feel better. Right, so should we jump straight in? So our first talk is actually a recurring speaker, returning speaker. So this is Holiday Extra's data scientist Rebecca Vickery, who's going to be talking to us about machine learning for everyone. So away you go.
Thanks, Alex. Okay, hi everyone. Yeah, my name is Rebecca. I work as a data scientist. It is my second time, I think, speaking at Code Harbour. It's really nice to be back. So thanks, Alex, for inviting me back a second time. It's a little bit different from the last time. Obviously, we're actually at a physical venue last time. Now it's online, so it's a bit different. I'm going to talk about machine learning. I'm going to talk about what I think machine learning means for business, sort of in the very near future. I'm going to talk a little bit about some tools and technology, I think, around machine learning that has kind of changed the landscape a little bit and is starting to make machine learning more accessible for a greater range of users, so sort of not just data scientists. I'm going to talk about why I think that's a really good thing, but I'm also going to talk about some kind of drawbacks and concerns maybe around that technology as well. So this is a really famous quote. Data is the new oil. I suspect that most people have probably heard this before because it's been really used a lot for a long time. So basically the point of this quote is that, you know, data is really valuable. It's as valuable, at least, as oil to businesses. But really data itself is not valuable intrinsically on its own. It doesn't really have value just in the collection of data. It's kind of like if you're a business, your data is very bespoke to you. So it's not like you would sell that data to another business because it probably wouldn't be useful to them. And even if it was, that business would probably look very much like your business. They'd probably be a competitor so you probably wouldn't want to sell it to them. So data on its own is not valuable. It's really the insights in that data and how you use those insights that is the valuable part. So Amazon, for example, obviously a massive company. They collect an absolute ton of data about their sort of processes, customers, how the customers are sort of interacting on websites, sort of all the information about deliveries and how their warehouses operate and things like that. They've got so much data, they've even created their own tools around their data that they actually sell. So things like Amazon Redshift, the database and things like that. But again, it's not that data that's valuable to Amazon. It's the systems that they build on top of that data that use that data to create experiences for customers, optimize some of their operations, sort of in things like those sort of warehouses and things like that. But it's those systems that deliver the value and make that data really useful. And there's a common tool behind all of those systems, and that tool is machine learning. And I think over the last sort of 10 years or so, machine learning has kind of gone through a sort of a hype cycle. So I think there has been a lot of hype around it. Sort of it's been seen as kind of this magical thing that you kind of bring into your business and it's just going to create these amazing returns. And then I think you've had obviously this kind of bit of disillusionment when that value hasn't necessarily always been realized, especially by, outside of the tech giants really. But I think with the way that technology has moved on, particularly in the last couple of years, I think we are starting to get to the point where we have got the tools and technology for most businesses to reach sort of productivity with machine learning. And in my role as a data scientist, obviously I've been using machine learning for a few years, but it's slightly different to how I'm kind of using it now, I think, especially post pandemic. I'm in a business, I'm in Holiday Extras, it's a travel company, so we have been impacted by the pandemic. So the way we do things has had to change a lot. So we haven't got the budgets that we used to have and things like that. So I sort of started to think about my role. In order to kind of focus on what I really need to do, I started thinking of my role more as the data value extractor. So I am sort of or machine learning, the tools that I'm using, is the thing that I apply to the data to actually realize the value and the usefulness of that data. And I think one of the problems that we've had around kind of tools and processes and the sort of people that can employ machine learning is it kind of creates a bottleneck. So I think at the top you have all this data, and I think actually businesses have got really good at collecting their data and investing a lot of money in the collection and the storage and kind of processing of that data. But the investment at the other end around sort of actually using that data and actually realizing that value and realizing the usefulness that really exists in that data kind of probably doesn't quite match, I think. And for other reasons as well, there's this bottleneck towards realizing the value of that data for a lot of businesses. And I think it's a couple of reasons. I think one is that, machine learning has kind of to date been largely deployed by just data scientists. Data scientists are quite specialist, so there's a bit of a talent shortage, I think, there. And also it's quite expensive as well. So having a big team of data scientists is quite an expensive thing. And also the tools and the processes, the way that data scientists work is quite different to kind of other roles in the business, like software engineering or analytics teams, where they turn around things in 1 to 2 week sprints or something. Data scientists, traditionally data science projects has been a lot longer, and it doesn't really align as well with those other parts of the business. And so what I think you find is that machine learning becomes a really, really big deal. So just to get one model in operation becomes this massive project just to do one thing. And I think the thing with machine learning is, and I think this is part of why there's this hype and then this disillusionment, is that machine learning, people sometimes think that, you would deploy one model and it's going to have this huge impact. But actually machine learning, generally speaking, I think, is applied to lots of areas of the business, and it optimizes little bits of the business, and kind of you get these small incremental gains from each model. So rather than a big model that just gives you this massive amount of value, it's these little incremental gains that actually, if you do lots of them, the value is really, really high. But of course, at the moment, having this bottleneck, having this way of working, it means that actually, machine learning being a big deal to kind of implement even one model, it sort of stops you getting those gains, and instead you just get one small incremental gain in a really long time period. And so over the last couple of years, and what my talk is really about, are these new tools that have kind of come out. I mean, some of them are older than 2 years, but I think it's maturing at this point. And these tools that kind of seek to kind of solve some of those problems. So some of these tools optimize certain parts of the machine learning process. So some of them optimize deployment, some of them optimize the model development and things like that. But they all kind of seek to kind of streamline that process and actually kind of make it more accessible to deploy lots of machine learning models within a business rather than sort of one or two. And so what happens with these tools, I think, is that machine learning can stop being such a big deal to deploy and start to be used as I think it should be, which is just another tool. So rather than any hype around it, it's just another tool that we use, and it's quite a valuable tool, I think, as well. So obviously I haven't got time today to talk through all of those different tools. I would like to, but I can't. So I wanted to pick one, and one that I have a lot of experience with. So this is a tool that I've been using heavily probably for the last sort of 6 months or so. I've actually sort of deployed models, got models in use in the business with this tool. So I kind of wanted to focus in on that because I have got experience of it actually working really well to solve some of these problems. So that tool is Bigquery Ml. So this is a Google tool, so it's part of the Google Cloud platform. So it is kind of limited a bit there, but it's a really, really good tool. Essentially, we've had the debate about SQL, SQL. I might use that interchangeably throughout the talk, because despite the fact that I've been working with SQL for 15 years, I still am not sure what is the correct pronunciation there. So I may use that interchangeably, but basically it is just machine learning written in SQL. So the advantages of that is that SQL is the language of data. Data is the thing I start with. Obviously, we can't do machine learning without data. It's the thing I start with any machine learning model, is writing a SQL query to extract data. So with Bigquery Ml, I don't have to extract that data into another tool, then write another model in a different programming language. I can write that model right where my data sits, which is in this case in the Bigquery kind of web UI. This is a model training query. It's just a few lines of code, really, really simple. And when Bigquery Ml first came out, I think a few years ago, I looked at it. It initially only supported kind of regression-based models. So I looked at it, I thought it was a really fun tool because I thought, oh, that's really interesting, like being able to write machine learning in SQL. But because it only supported like one sort of model, it wasn't really, I didn't think it was very viable for like business use. But I think about 2 years ago, they started adding in the support for all of the models. So now all of these are kind of like the most common types of machine learning algorithms that you would used for most business use cases. And they've also brought in support for things like their AutoML tools, and AutoML are the API machine learning models. So they're like pre-built, and you just put your data in and they give you a machine learning model. So there's support for that. And there's even support now for customized TensorFlow models. So even those kind of quite bespoke use cases, there's support for that as well. So it really is, I think, has become like a really viable tool for business. And sort of, I've sort of talked a little bit about how, you know, the training of the model happens within the database and within the place where my data sits, which massively sort of reduces down the time to kind of build those models. All of the models development cycle kind of can happen as well in SQL. So evaluation, you can just write a little query to evaluate the performance of my model, so I can see how well it's doing, how good it is actually making those predictions. And you can even view like this, which is a little dashboard. It sits in the sort of web UI for the Bigquery tool. And you can just view it immediately there. It's just, it's so much easier. And similarly, you can make predictions on new data. So when you want to actually use the model to make predictions, again, it's just an SQL query. It's just calling ML predict. The model itself sits in the Bigquery database alongside my data as well, which is really, really good. And obviously machine learning model, it's all very well having a machine learning model. Again, it's still not useful unless I can get that somewhere where somebody can use it. So that might be an operation on a website. It might be serving sort of an email mailing list or something. It might just be a dashboard actually somewhere for somebody to view, but it needs to be put into operation. And I have had experience and sort of success with using kind of SQL throughout the whole process of that, using Bigquery Ml. So because it is all SQL queries, so basically this is a really good example of a sort of loose infrastructure that I'm kind of using at the moment for that. So the training happens in SQL in Bigquery Ml. I'm then using an ETL tool. In my case, it's Airflow, but you know, it's an ETL tool. You know, it's SQL. So any kind of ETL tool is, you know, probably would work the same way. Again, it's mainly a SQL query there. And then we use Looker for our BI tool. I don't know how familiar people are with that, but it's basically just a BI tool, so you can create dashboards and stuff using SQL. And Looker was bought by Google, I think it's a couple of years ago now. So because of course it's now owned by Looker, they have really good integration with Bigquery ML. So literally with a SQL query, a little bit of their sort of custom code called LookML, I can create a dashboard, which is really lovely, of monitoring my model. And monitoring is really important because once the model is actually in production, we want to make sure that it's performing well, that it's performing as it was when we trained the model originally, and it's continuing to perform. So that's a really important part of the whole sort of life cycle of machine learning. So Bigquery ML is one example of these kind of tools, and it does two things, I think, for sort of in terms of how I was saying about propagating machine learning and solving that sort of bottleneck. One is that because it is SQL, which is a really simple programming language to learn, and also it's a programming language that a lot of other business users have and know, so things like data analysts, software engineers, other kind of data savvy business users might know it. So it's viable now for other business users to be able to build machine learning models, not just data scientists, because you don't necessarily need to have all those, you know, specific kind of knowledge of a wide range of machine learning libraries and different programming skills. But it's also a really useful tool for myself as a data scientist. So for me, I think what the problem it solves is speed. So before, you know, like I say, it would take quite a long time for me to develop a model and then get it into production. The actual model development time is massively reduced, and partly because of the fact that I'm writing my model in, you know, just one language. I'm also writing it in one tool. I'm writing it right where the data sits, which is really good. It's really good for prototyping really fast. So basically, if I'm going to start building a model, the first thing I do is write a SQL query. So I can then, if I want to sort of see if that actually, I mean, as a prototype, I want to see, is that data actually predictive? Because before I start building a massive, going really down the route of building an in-depth model, I want to just get a rough idea. If I can write a SQL query, I can add a couple of lines of code, train a model and evaluate it, you know, all in the one tool. And it just massively reduces that time. And also it is viable. You know, I have used this for relatively simple use cases so far, but I have used this to actually deploy machine learning models as well. So it's not just for prototyping. So it's a really good tool, and obviously talked about how much I like that tool. It's really, really useful. Obviously there's lots of other similar tools out there. I mean, I think they're the only one that does machine learning written in SQL, but I could be wrong. But I think it is a great tool. I think there are a few things we should be not necessarily concerned about, but you need to watch out for, I think. So I think the thing is, I've sort of talked about machine learning as being, you know, just another tool, and we should use it. And I think we should think like that. But I think obviously machine learning is a little bit different in that it uses data to kind of write its own set of rules to make the prediction. So there's some kind of there's some areas of risk in using machine learning. So I think we need to be careful around you know, just going out and just using it everywhere and getting everyone to use it. I think in a business it's important to kind of make sure that the people that do use it have the right kind of training, have the right understanding of what can go wrong with machine learning. The other thing I think with Bigquery Ml at the moment is it is very much a black box. So one of the good things about Bigquery Ml, which I haven't mentioned yet, is that with a machine learning model, you have to do some data pre-processing before you put the data into the model. So for example, a model can't handle anything that's non-numeric. So string data, for example, it can't really handle missing values. It can't handle dates and times and things like that. So ordinarily I'd go through a whole process of changing that data to fit the machine learning model. And that's quite a long process. So basically what this does is you can literally just throw that data into the model and it'll do all that pre-processing, which is really, really, really good, except for the fact that at the moment there's no real way of understanding what exactly Bigquery Ml has done with that data. So the thing with that is that then when it goes into production, there might be some kind of unintended consequences there if I don't know. And also as a data scientist, I like to kind of feel in control. I like to feel like I can trust what I'm doing. So that just makes me feel a little bit like nervous. So what I have been doing, especially with the models that I'm deploying, is I kind of I do my prototype in Bigquery Ml, build it in my Python libraries where I can see what's going on, and then I recreate that same kind of thing in Bigquery Ml. I feel like it really needs to have a bit more sort of explanation around it, I think, to be really, really useful. The other thing I think that's obviously that leads on to is concerns around bias. So obviously machine learning, as a tool, it learns patterns that exist in data. In the world, we do unfortunately have biases, and they can be reflected in the data that we use to train our models. And if we're not careful, they can end up kind of creating like probably not necessarily less than ideal experiences potentially for people. And so that is a bit of a concern, and with it being a black box, there's no way of kind of us understanding why the predictions have kind of potentially been made by those models. And so, you know, I think there's a risk there that you could end up with kind of like bias in your models. And with our Python libraries that I generally use, you have tools in there so you can look at predictions and understand why a certain prediction has been made, so you can easily spot those biases. So I think again that's something that's missing from these kind of tools sometimes. But I've talked about, so originally I started the talk with saying about the quote, data is the new oil, and I've said, you know, it's not, data doesn't have the value, we need something else. But data really is the new oil, because machine learning, without data and without really good data, we can't build machine learning models. We have to have that data. But really, like oil, you need a car engine or something like that to realize the potential of oil. For data, to realize the potential of data and to realize that value and usefulness, we really need machine learning to sort of get us there. But I do think with these tools that have kind of been developed over the last couple of years, I think they are really, really good. And I think they will get us to the place where I think we need to be, which is why machine learning, rather than being a big deal, is just another tool that a business can use. But like any tool, it's really important to use it only when it's needed. So again, machine learning isn't the only way to realize value or usefulness of data. There are sometimes just a calculation can suffice. So only use it kind of where needed. It needs to be in the right hands. So again, that goes back to sort of some of the things I've been talking about around training of people that are going to use machine learning and having understanding of those risks, and then safety precautions. I think, you know, having an understanding of why a model's making those predictions it is, and things like that is really important as well. Yeah, thanks very much for listening. If you are really interested in machine learning, I write a lot of stuff on Medium, so you can always find me on there. I've got loads of articles if you're interested, but thank you very much for listening. If you've got any questions, I'd really like to answer them.
Thank you. I have a quick question. I don't necessarily know if this is something you could answer, but so I did a bit of a data scraping as part of a project about 3 or 4 months ago, and we've now been commissioned to basically take that data and we're going to do machine learning on it.
Yeah.
I did the original bit of coding in Python, so
Yes.
my plan was, I'm just going to do it in Python still.
Yeah.
Would you suggest otherwise? Because Python, I'm still new with it, and I haven't really done any machine learning, so I'm kind of open to any suggestions.
Yeah, there is an amazing library called PyCaret, which is a Python library. It is a wrapper for scikit-learn, which is kind of the sort of one of the top machine learning libraries. PyCaret is really, really good. It abstracts away. I mean, it does something similar to, I mean, basically BigQuery, BigQuery is only good if you're probably already got your data in BigQuery, basically. But PyCaret is Python library. It abstracts away a lot of it does a lot of the same things to Bigquery Ml. So it does the pre-processing on the data automatically, does a whole lot of stuff automatically. I think probably the benefit of PyCaret is actually you can see a little bit more of what's going on there, and I think you can change it a bit more. So like with the pre-processing, you can ask it to do certain things. You can set up like a config file, I think, to get it to do things a certain way and stuff. So it's got actually a bit more control, but it is really, really simple. It's a really simple library. So I definitely think that's one that I would go with for that, definitely.
What sort of, how does the data need to be inputted? Because at the moment,
yeah,
all I did was it was very, it was proof of concept. So my
yeah.
data was just in a CSV file. So
yeah.
Obviously we're probably going to put it in a SQL database, but what format would it need to be?
So you could do two things. You could either put it into a SQL database and then write a query and then use like a tool to get the data in via query. You could also read it in with Pandas. Have you heard of Pandas? That's the kind of data manipulation library. Yeah, so you could read it directly, read the CSV file in there. I'm assuming it's like is it a labeled data set? So it's got like a label that you're going to try and predict on, something like that, or is it something different?
Completely.
Okay.
Got to that point. We've literally just done the scraping, got all the data, and then we had to find a way to show it, so we put it in a CSV file. So it's
So
I'm like 3 steps.
Sure. Oh no, that's fine. So basically it depends. I mean, if you're using what's called supervised machine learning, then you'd have a label for your data, and then you'd have your sort of what are called features. So basically each column of data would have a different kind of data point in it, and then basically you'd be wanting to build something like either a classifier or something like a regression model. So what you would do is like you could either read the CSV file in or get it in from a database, and then you would sort of separate out the features from the target. And you then want to split your data into sort of a training set and a test set. So you can train your model on some, and then you can validate the model and see how well it works on the test data that it hasn't seen yet. So it's kind of like those kind of things. But I'm happy to, if you just drop me a message or something when you're in the process, I'm really happy to whatever.
Just about to say, I probably will do that.
Yeah, no, absolutely. I really love machine learning. So I love talking about it to people. So just do that, please. I'd love that.
Oh, thank you. So anyone else want to ask any more questions before I hog all the time?
Yeah, I was just going to ask, how do you sort of balance the output that you get from the machine learning with obviously some of the concerns you've mentioned?
Yes, so I think exactly. So I'm very aware of those risks. I'm particularly biased. I'm quite passionate about that. I want my machine learning models to do good things for people. In terms of my job, I want to create a better experience for customers, and that sort of really drives me. So I'm really aware of those things. And for me, it's about So what I would do is, what I'm doing now is with Vickery Ml, you can't see anything around those kind of risks with the output.
Yeah, so it's not it doesn't give you like any sort of indication of how it processes stuff.
No, it gives you no indication. So what I'm doing at the moment is I'm actually building I'm building like a prototype in Bigquery Ml. Then I go to my Python tool where I know I've got all of those tools to evaluate that sort of stuff, build it again in there to evaluate that it's working, and then I match the performance between the two systems, which obviously isn't the best thing before I deploy a model. But Bigquery Ml does abstract away so much stuff that it's worth my time doing that at the moment, but I do still rely on my Python to actually evaluate that model and to understand. So there's some really good tools. Eli 5 is really good for evaluating model performance. Basically, it'll tell you if you feed it the prediction, it'll come back and say all the features and exactly like how it's made that decision. So say if you've got something like a distance feature in there, it'll say that it's made this prediction because the distance is greater than this amount or something like that. So you can really understand, or if you've got an age, let's say age is probably something that might be biased, you know, it would say this prediction has been made because this person is over the age of such and such age. So I still rely on Python heavily for that kind of thing.
Yeah, cool, thank you.
That's okay.
Any other questions? In that case, can I quickly ask a sort of follow-up?
Yeah, of course, yeah, no problem.
It was just because the thing that I'm going to be doing is actually topic modelling. Does it still
yes.
work? Or is
no, that's like, so it's on text data, is it?
Yeah.
Yes, no, so that's slightly different. Yep, so that is going to be, it might be labelled, I mean, it depends. So topic modelling is probably just going to be taking the text as it comes. So basically, if you just literally read in a CSV file or get the data in via SQL, you just want a column with your text data in it, and that's pretty much all you'll need. And then that should be fine for all of the libraries. I can't think off the top of my head. There's things like, can't think of the name of it now, like NLTK, which is a really good language processing Python library.
PyCaret.
PyCaret. I don't know that PyCaret supports text data at the moment. I don't think it does, but things like NLTK work quite well. I've got a couple of Medium articles actually that I wrote about natural language processing, so I can drop those on LinkedIn for you if you like, and send you a message with them in.
Cheers.
Because they've got because I always try and write sort of things that are very beginner friendly, so they should hopefully be
perfect,
easy to follow. I think.
All right. Any other questions?
Can I ask a question that is probably very dumb, and if it's too dumb for this illustrious group, then please feel free to say, because I can read it up somewhere. So I've when I was a professional software engineer, I worked a lot with databases, very familiar with SQL, and I suppose the way that the data was used in those days was by producing reports, and those reports were generally largely predefined, but hopefully gave the information that people needed to make the decisions that they needed to make. What I haven't been able to work out, to me, machine learning is a bit nebulous. I still don't know really what it is.
Yeah.
So it would be helpful to have a specific example of what sort of thing is being used to create what in order to make the decisions.
Yeah,
or
sure.
Do we even understand if the machine is making the decisions? Because I'm really, really vague about all of that.
Yeah, sure. So yeah, that's a really good point actually raised. So about reporting, because obviously that's another way that data is already used, and most businesses are quite good at using it for reporting and saying what happened yesterday, how many sales did we make yesterday, or something like that, and then making a decision based on that. I think there's a couple of things with machine learning. One is obviously it's predictive in its nature, so it can say based on what happened in the past, we think this is going to happen now. So it goes a little bit further than just saying what happened yesterday, which is obviously quite useful for decision making if you have a good idea of what might happen in the future. But I think where the power is in machine learning is that as a human being, I can only analyze so much data. So I can maybe look at like I don't know, 12 months of sales, and I can kind of analyze a pattern in that or something. But when you start working with lots of very big data, and like some of the use cases, like let's say recommendation is one that probably most people know about. So things like Amazon use it to recommend products to you, and Netflix, when you watch sort of streaming services, they'll say what to watch next or whatever. That is based on processing absolutely huge volumes of data and using kind of mathematics basically to calculate patterns that exist amongst all those users and all those products, and sifting through and then finding the best options for that particular customer. So it kind of is where it's useful is in terms of doing things that are more beyond what human could analyze effectively. I think that's the main thing. Does that kind of answer the question?
Yeah, it does. And having the Netflix example was very, very helpful.
Oh, good.
Yeah, so it's sort of reading the data and I suppose making inferences from it.
That's exactly right. Yeah, inference is a really good word because it is very similar to that. Yes.
Okay,
Yeah.
thank you very much for
Yeah.
that. That's
Oh, that's all right.
up.
Good. I'm glad.
Anyone else? Going once, going twice. I don't want to cut anyone off if someone wants to ask something. All right, I think we're done then.
Thank you. Thank you. Oh, thank you.
Yeah, thank you very much.
Okay, so in that case, I will pause the recording here and we will come back on in 15 minutes. Is that right with you, Phil? Great. Okay, thank you so much. Where's the pause button?